There we go. Awesome. Cool. Let's get into it then. This course is called, wait, does everyone see this one?
Yep, we
All
see
right.
it.
So this course is called Systematically Improving RAG Applications. Primarily, it's motivated by some of the experience I've had consulting a couple of RAG companies in the past. And mostly it's around some of the mistakes I've seen people make. And then more importantly, actually building a system that becomes the flywheel that you can use to iteratively improve some of the applications that we build. And so first of all, I just want to say, thank you for trusting us. I think there's a lot of hype in the AI space, and really my goal is to give you a process to improve the application that you're building. And the goal really isn't to sort of, give you like 4 or 5 tricks to apply or have some kind of advanced techniques that you're going to use. Really, it's going to be around the processes that you build and the flywheel that you're able to spin up in order to give you the data you need to improve the systems that you build. And so we're going to go over an agenda for this short presentation, and then we'll jump into the actual first week, which will be a little bit shorter because we're running low on time. So who are we? So I am now an applied AI consultant, mostly helping with a lot of strategic work, right? So a lot of teams have, strong engineering teams, but they're less familiar with the quantitative side of machine learning and AI. And so I come in and help them sort of plan out the roadmap, make sure the team is running effectively. And a lot of the work has been around RAG, query understanding, prompt engineering, and et cetera. And so I've worked with a couple of companies in the past year or so, focused on that. My background is actually in building recommendation system frameworks and observability tools to improve RecSys. And a big theme for this course really is the fact that RAG apps look a lot like RecSys. In 2017, 2018, I mostly focused on building vision models to do multimodal search and building things like variational autoencoders and generative tools to improve the way we do search and recommendation. And then lastly, I spent a lot of my time sort of curating, doing a lot of data curation, right? And this is going to be a bit of the course as well. And so all these skills kind of accumulate to being very applicable to RAG. And then previously, before that, I was working at Facebook doing a lot of cybercrime detection. It's kind of like a RAG app for all the evil on the internet, whether it's spam to terrorism. And so I have a lot of experience sort of building a lot of these search tools. And so the focus of my career in the first half was really about making vision work, right? Given that vision had worked in this deep learning era, and now I'm applying the same skills again to do stuff like make text work. Right? And so a lot of the stuff that we have around product search, recommendation systems, and product reliability, all the things I want to share with you. And I think a common question is, okay, if you're so good, why don't you build a company? In the past 2 years, I've actually had an RSI injury now. And so since I can't code as much, I spend a lot of my time thinking about what are the best practices and the patterns that I'm seeing in the industry. And the work that I can do now is highly leveraged to do much more advisory and education. Dan?
Yeah, so I'll be assisting Jason with this course. Who am I? So I was a hobbyist machine learning practitioner until about 12 years ago. At that time, I got second place in a Kaggle competition with a $500,000 prize for first place, but no prize for second place. So that was first loser in some meaningful sense, but I've been doing ML or AI professionally since then. Was an early employee at DataRobot when they were hiring people who were just consistently doing well in Kaggle competitions. Um, Soon after that, I joined Google. And the most interesting thing that I did at Google was build an AI education platform that was used by 45,000 monthly active users. Founded a company called Decision AI, which was going from conventional predictive modeling, combining that with the types of models that people build in Excel for making decisions and doing decision optimization. Sold that back to DataRobot. Led a team of about 40 engineers there. But then a couple of years ago, left that and started doing independent consulting. I've seen a lot of different workflows for a lot of different companies. My work, in contrast to Jason's work, tends to be for companies that are not tech-first companies, but I've worked for a lot of Fortune 2000 companies, advising them on generative AI projects that includes projects that involve RAG and other projects. So seeing these things applied in a lot of places, and excited to work with Jason on this course.
Sweet.
I'll jump in with course structure. So the first piece regarding course structure is I really want to make sure that everyone is in Slack. There are a lot of events. So we're gonna have 3 times a week where there's events. So there's a lot of times where there could be confusion. If anything is at any point confusing about course structure or is something recorded or anything else, please just DM me in Slack. That's available anytime. But then the course structure over the next 6 weeks is on Tuesdays, we'll have a workshop. This is an example of a workshop. We have a list of the topics for those workshops on the right. On Wednesday, we'll have breakout sessions, so those will be more interactive. The first 20 minutes of those will be you talking with others in the course. And then after that, there'll be office hours, which is really a chance to ask just questions and get them answered. I think that the Q&A from office hours based on other courses I've taught is something that people will really enjoy and will be a high point of the course for most people. And then on Thursdays, we are having guest speakers, and you'll get to see how they've worked through some very successful RAG projects. And then don't need to read them aloud, but the list of topics is over here on the right.
Great. All right. So I also want to go over a view of who everyone else here is. I think through some analysis, we found about like 40% of the people are co-founders and executives. The other 40% is like software engineers, MLEs, and data scientists. And I think this week will feel a little bit slow as we calibrate to everyone's level. But as we go through office hours, I can adapt some of the last 2-3 weeks of the content to make sure it's actually answering the questions you guys care about. And so let's just jump into a little bit about what a system looks like, talk about the playbook, and then I'll jump into the actual workshop slides. So I think the reason people need a system is because oftentimes companies waste a lot of time just like guessing what will work, and they tend to ask me questions like, do you think HYDE will work? Which embedding model should we use? And I think a lot of that time guessing should be spent testing new technologies, and having the right evals and right test harness allows you to develop a framework for evaluating new technologies and ultimately make better decisions in the process of prioritizing developmental efforts, right? And then also part of that system allows you to have some methodology and some standardized metrics to figure out what is working, what is not working, and what we should potentially highlight to a user and what we should sort of reject as the user is using our application. And ultimately, be able to get the resources we need to develop new capabilities is often very challenging without being data-driven. And so part of this course is making sure that we can actually be focused in how we propose, we find solutions. And ideally, you know, there's going to be lower anxiety when you're told that like we want to make the AI better. I think that's something that I hear all the time, but people don't really understand what that means. I think you guys are also probably very often just told, look at the data, and if you look at the data, you'll know what's going on. But that's oftentimes also very hard. And ultimately, I think everyone wants to drive better outcomes for the customer rather than just focus on like retention, rather than like just retrieval and generation metrics. You want to do something for the user. And so through my consulting, I've done that through like personal agent companies, construction workflows, workflow automation, sales, marketing, transcript data mining, and some due diligence work. And I've seen a lot of folks in the introductions page on Slack do very similar projects. And so the goal is to focus on experimentation rather than having a vague like idea of making the AI better, teach you guys how I look at data, what we're looking for, and how to find the signals, and ultimately figuring out whether or not the juice is worth the squeeze in terms of improving those signals. And the idea is like once we have this in place, once we have the flywheel in place, your success should hopefully be defined by just doing the most obvious thing over and over again, right? And the idea is that a better application is often a result, but it's not an effort. And then our goal is to really just execute this flywheel, review data, find segments, and improve those segments over time, and really, you know, do the boring work of making things better. And the idea that I'm really wanting to push is the fact that many people, right, maybe not in this audience because I've realized that this audience is a little bit more like senior, is that most folks think that it's going to just be retrieval, some prompt, and then some generation. But ultimately, what I see in a lot of production settings is that language models are used to route across multiple retrieval indices. We have filtering and scoring and ordering just like a 4-step recommendation system. But ultimately, I think too many people focus on the generation side of things before realizing that the data is not being retrieved correctly. And so if we can improve search, right, something that we have control over, generation will automatically get better over time as these models improve. And so what an application actually ends up looking like is a lot of web interfaces that hook into language models using things like planning and chain of thought and parallel tool use to hit these retrievers. Then we have the classical like filtering, scoring, and ordering tools. Then we have to take those prompts, turn them into the representations we want to put into a language model, and then ultimately get out some kind of maybe special UI beyond things like text streams, right? We might want to render profile cards if we're looking for contacts. We want to render PDF viewers with citations or have good feedback mechanisms to collect the information we need to improve the system, right? In simple code, it might look like something like this, where we have some query understanding layer, right? We have an answer prompt, and all we have to do is execute the search, order the results, format things, and then answer the question. And what this gets us is a place where we can build out a playbook where we can use things like synthetic data generation to speed up our ability to create fast evaluation data sets, right? Once we have that in place, we can deploy a system that collects real-world data. And once we have that real-world data, we can categorize the user intents and questions to find these segments and prioritize specifically on what segments we need to work on. And if we have the right data, we'll be able to identify like the volume of these segments, the priority of these segments, how difficult they are, and what the impact is to the customer, and then build these things into a production monitoring workflow. And the idea is that we just do this over and over again, right? Through production monitoring, we can understand what systems are failing, and we can make proposals to improve these systems. And they're often going to be more of a process and metadata extraction workflow rather than just like default, like making the AI better. Right? And by doing that, we can address the cold start problem by synthetically generating data sets and testing against different benchmarks. We can observe and instrument different strengths and weaknesses in the clusters of question types that we detect, and ultimately build new routers, tools, and capabilities. And again, it's just going to be rinse and repeat. And so week one, we're going to talk about just the initial implementation and really focus on why we want to have synthetic data generation and fast evaluations. And then week two, I'll go over how I think about things like classification and understanding these different topics and really focusing on understanding what we should do in these different situations. And the rest of the weeks will mostly go over some of the techniques and tactics I use to improve specific capabilities, and then ultimately thinking about how we can collect feedback and build out better UI and build out some of the customer-facing side of things. So instead of a Q&A, I'm actually going to just jump into the slides for this week. And then hopefully we'll have some time at the end for any questions. And then after that, in the general Slack channel, there's a Dory link. And so for any questions you have that we want to answer in office hours, you can just post that in there. And so I first want to talk about some of the pitfalls developers make, right? Go over the playbook one more time, show some code examples to think about how we do synthetic data generation, and then I'll ultimately go over some potential homework for everyone for the rest of the week. So the truth is that when I've looked at almost every company I've worked with, when I hear like we need complex reasoning, it often comes from a lack of user empathy and understanding what the user actually wants. And the solution is ultimately going to be building much more highly specific tooling that the users actually care about. In practice, we fall into this vicious cycle where most metrics are very vague and like feelings based, right? Things look better if things don't feel right. And we lack a lot of superpowers that we need to actually have our customer be happy with the results, right? A common example is everyone wants to build like search over personal data, but that ends up being a feature rather than some benefit the user is going to get. Whereas if we can build more specific tools like a meeting preparation tool that can search over personal data, but now the outcomes are a little bit more clear. You're going to be more prepared. You're going to like close the deal, have better sales, have better conversion, et cetera. And then lastly, I think too many companies are focusing on generation before having good search evaluations. And what this results in is that looking at the data does not actually result in recommendations we can use to improve the systems over time. The other thing I think people are really lacking is really focusing on the leading metrics for success rather than the lagging metrics. A lagging metric is something that's going to be easy to measure and hard to improve, right? They're going to measure past outcomes, and they're going to be like very unresponsive to change, right? So these are the things that people really care about, like application quality, churn, or satisfaction. And a simple analogy is like, being strong or losing weight. You can weigh yourself every day, but you can't really change anything about that. You can figure out if you're strong enough to lift up some heavy object, but knowing that isn't going to change anything. And so I really want you guys to think about the fact that really what we want to think about are leading metrics that are going to be harder to measure, but easier to change, right? And things are going to predict future performance. And in the next couple of weeks, really the thing we should be focusing on is being able to run as many experiments as possible, right? This is going to be much closer to counting calories, burning calories, and just figuring out like what your workouts are going to look like. And if you can set concrete goals for these leading metrics and set goals against the number of experiments you're going to run, then through that experimentation, we're going to have better intuitions on what retrieval methods are actually going to work and what other indices we're going to have to build to improve this product, right? It's not going to be the case that if we go from 4.0 to 5, your application is just all of a sudden going to work. It's going to be the tools that you design, right? And we want to make tools that are designed for users for the outcomes they want to generate. And ultimately, I think this is a symptom of something I like to call like absence blindness and intervention blindness, right? Absence blindness just says that you can't really fix what you don't see. Everyone sees generation and latency. Not everyone can see the poor recall or the bad representations, and so that's what they want to change. And then people just want to try a bunch of things because they want to feel in control. And again, generation and applying different techniques you see on Twitter or every new paper that comes out feels like you're in control. But a lot of the time, it's actually better to actually have simple evaluations and realize that the better choice is to do nothing, have less tech debt, and figure out what can we control in the retrieval and what can we offload to better models in the future. And so we'll go over a quick overview of the 4 steps and then dig deep into the synthetic generation part. So the first idea is that if you don't have any users, you really want to just generate synthetic data to start off a conversation with the team, right? By having the synthetic data, we can test things really quickly and really just set good goals against how many experiments we can run every single week. And then the idea is that with that, you can actually go out and collect real world data and blend in that data with your synthetic data generation. If you end up looking at retrieval and evaluation metrics, you find that precision and recall lets you test things like whether or not you want to use lexical search, what forms of lexical search, whether or not semantic search is going to be worth it, and whether or not re-ranker is going to be worth it. Whereas if you focus too early on things like factuality or LLM-based generation, tests are going to be very, very slow, right? Each test might take 10, 20 seconds to run versus 10 to 800 milliseconds per retrieval test if you want to like use evaluations, right? These tests are also going to be pretty expensive and very slow, and it kind of slows down the team and being unable to run these experiments very quickly. And again, so many different experiments that you can run in the first week or 2 of having synthetic data are mostly going to be bound by how quickly you can run the evaluation suites. And so by focusing on retrieval metrics first, you can have more experiments much more quickly. And lastly, I think most teams I've talked to only have like a dozen or 2 dozen different evaluation examples, and it's really good to have hundreds of examples to figure out that we're actually capturing a good basis for the questions users want to ask. And with hundreds of examples, you also make sure that your variance is low enough that any change is actually significant. And again, if you have hundreds of examples for generation evaluations, they end up costing like $300 per run and take like 2 hours to run. And again, just like slows down the cycle. And to be more specific, a retrieval evaluation could just look like, for any kind of question, like what is a powerhouse of the cell, can we retrieve the right pages? Those are simple equality checks that we can run very easily. Whereas if we just test generation and factuality, the format of the results are going to be very sensitive to change. And on top of that, the LLMs that evaluate the answer quality might be sensitive to random things like how well we do citations or how long the answer is, right? And I think most companies I've worked with so far don't really have a good idea of how easy it is to recover the data, let alone generate answers. Another example is, if I ask the question like, how do I contact Jason? Making sure that we find the right document is going to be very easy to do, very quick to iterate on, versus sort of the format of the generation or what kind of information I include. And I think the more companies focus on generation evals too soon, it kind of washes away a lot of the retrieval issues that might go unnoticed. Just as a quick overview, precision and recall are effectively the things that I look at the most, right? I think there's like F1 score as well, but for the context of language models, recall is the thing that we want to focus on the most here. And recall is for all the documents that I retrieve, how many of them are relevant? This is very akin to the needle in the haystack problem, right? And this is effectively our ability to find the right context for our language model to answer the question. Whereas precision is going to be a little bit more tricky to reason about. One is because as language models get better and better over time, these models are tuned to have better recall. And so they're going to learn to ignore a lot of the information. That said, dumber models will often be more confused with irrelevant information, and bad precision is ultimately going to result in having to pay for more tokens that are not productive. And so there is some trade-offs, but in the beginning, I think the real goal is to just maximize recall and use the models that are as smart as possible. And then as you use dumber models, figure out what kind of trade-offs we need to make. I'll give some couple of examples in the case studies I've seen with some of the clients I've worked with. The first one is one where we were doing a lot of due diligence call processing. Right? Consultants would do like 15, 30 interviews with experts, and the consultants would have very good perspectives on who said what in those conversations. But when we actually had AI-generated reports, one of the feedback that we got was for certain fields, the consultants noticed that we only cited 3 out of the 6 people that they know spoke about this topic, right? And so here, recall would be about 50%. The team really expected them to have all these 6 quotes, and they lost a lot of confidence in the system that we had built. So we had gone back into like the 5, 6 reports that we had generated, spent a lot of effort building out really good question chunk relevancy data sets. And through a bit of pre-processing, we were able to improve our recall from 50% to 90%. And that effectively allowed us to continue the sales conversation with these consultants and really focus on the fact that, like, hey, if you give us this feedback, we will build the evaluation set that matters, and we will report back these improvements. And as long as you work with us, we'll consistently improve over time, right? And the real focus here is just leverage as much customer interaction as possible to motivate your test suites, right? I think people will oftentimes make up very like bullshit question answer sets in hopes of having good scores, but really having these specific tuned sets will really give you the ability to give customers the ability to have confidence in the system that you're building. Another example is actually in the multimodal space. Construction workers wanted to ask questions regarding blueprints, and one of the problems we had was we weren't able to retrieve the right images, let alone answer questions about them. And what we had done in the beginning was a visual language model prompt that took an image and made a description of that image. And we searched against that description. And what we found was that the performance was very low. It was about 27% recall for 75 images searched, right? And basically what we realized was that the image captioning data sets were not very good at describing blueprints. But if we experimented with things like chain of thought and giving these language models more context as to what kind of questions these images had to answer, we would be able to generate progressively better and better descriptions, right? And so we tried a bunch of different prompts. We had like 12 different prompts, 3 different models. And in the course of 4 days, we were just able to iterate on this summarization prompt, this image capturing prompt, and we got recall from 75% to 85%. And what this allowed us to do is build a system that was good enough to actually show to users. And then once we had this real user feedback, we can then analyze what kind of questions people were asking. And in this case, we found that over 20% of the questions people were asking about blueprints were just counting things in the diagrams. How many doors are there? How many rooms were on the 15th floor, stuff like that. And this basically justified an investment to run bounding box models first in order to count the rooms and the assets in an image. And now we'll be able to say, how many rooms in the 13th floor had like 3 bedrooms. And we could do that just by doing, YOLO over bounding box models over the diagrams, right? And so because we had this very tight feedback loop and this very tight subsystem to search images, we could iterate very quickly to build out these baselines. And then changing these prompts, for example, becomes a very easy experiment to run. In this example, we only had maybe like 300 images. It would take about like 20 minutes to process all these images, and then we would get test results very quickly. And so if these things take like 20 minutes to run, you can imagine how many prompts you can iterate over time, especially with different models and different latency trade-offs. And if you have no users to work with, this is where synthetic data becomes very, very useful, right? Fake it until you make it. With synthetic data, what you can do is, if you have no user data, the easiest thing you can do is take whatever asset you have, whether it's a document, an image, a table, or a text chunk, and ask a language model to produce questions. And the simplest test you can run is just comparing whether or not the chunk ID of the document that you had generated the answer for is retrieved in your search system. And here your search system could be a multi-hop search system. Maybe it could be a single search system with full text search, right? The idea is that the data set that you produce is going to be very simple, right? Chunk ID is returned in this search query for a list of chunk IDs. And what you're going to find is usually these questions are pretty bad, but it's going to give you a starting point to figure out what are the good questions people answer. To make that data set much better, if you have user data, you can use the user queries as few-shot examples for better generation. You can also, for these questions, generate hypothetical text chunks and put them back in your data set. And then the idea is that, okay, if we had a question, could we have made an ideal text chunk and could that have been recovered? And again, you might feel like this is too easy for some problems, but it's actually not the case. For like polygram essays, it is the case that for synthetic data, you get like 97% recall, whether you use text search or not. For something like GitHub issues, we found that you get like 60% recall right off the bat. And you realize really quickly that we're missing a lot of filters and contextual information that we need to include in the prompts, include in the text chunks to really get good results. If you have a lot of user data and a lot of text chunks that have been retrieved, you can also use language models to produce weak ranking data. And then we can review these weak labels to create correct labels, and again, continue to add to this precision recall evaluation suite. And as you keep doing this, as you see that there are low recall answers, really just ask yourselves, like, could these questions ever be answered by the system we have in production? A simple example we found was we had a lot of user questions asking for document ownership, or when was the last time a user modified this document, and that metadata was just not available. But because we had that information, all we had to do was produce a text chunk that appended, last modified date and last modified by user information, and now we were able to answer all these questions. Right? And the idea is that by collecting all this information, whether it's every demo, every user interview, if we can collect the thumbs up ratings, allow users, for example, to delete sources or upvote sources, this question chunk ID data set is effectively going to be the data set you use to build a training data set in the future, right? Today, it might be 50 to 100 evaluation questions to tell you how good your app is doing. But if you can get to 1,000 or even 10,000 pairs, now you can train a model that you can use to improve your system, right? And that becomes the moat for your business. I also want to highlight the fact that for a lot of these generation prompts, they're pretty long, right? I think one mistake people often make is they'll have a generation prompt that just says, oh, what's in this image, right? Or here's a text chunk, give me a question. And what ends up happening is the prompts I use in production tend to be very long and very detailed, and specifically give a lot of context to the language model as to why we're doing these tasks, right? And here I give a description of the product that we're actually building, the document that we care about. I give it example questions, and these example questions might be a function of what kind of document type. For example, if it's a procurement form, if it's a tax form, this is, again, more information we can give. Because ultimately, for real world problems, specific documents tend to have common questions that we have answers for, right? And having that in place allows us to get better results. Same thing with ranking. Here I have some context around why we care about the relevancy of the chunks. We give it a question with a list of text chunks, right? And we get some structured evaluation back out, right? Here I want to return the chunk ID, maybe some reasoning as to why that chunk is relevant, and then a score. And now this can be used to not only improve things like my precision and recall metrics, but potentially ranking metrics down the line. The ranking metrics are kind of an aside, and most of the time you won't have to worry about them. But if you do work in a case where you want users to evaluate the citations, then ranking information is going to be very valuable. If you find 6 or 7 chunks, you want to make sure that when users evaluate the quality of the result, that they're clicking on the right things earlier in the list of citations. So now we're going to jump over to Dan, and he'll show some notebooks that highlight some of these examples.
Thanks. Actually, before we do the notebooks, we're going to take a break. I'm going to launch a quick poll. It's all multiple choice, but we want to get a sense for who's in this course. So you should all have just received notification about a poll. We're just going to take 1 minute to give you a chance to get through it. And then we'll jump into some specific code.
Yeah, let me also share the Dory link in Slack.
Okay, for those interested, I'm posting a screenshot of the results. I believe that you cannot see, you guys can't see the results in Zoom, but I'll post a screenshot in the general channel in Slack. I think the most important question to me was have you used synthetic data evaluation, which is something that Jason was just talking about. And this is this idea of creating your own question answer chunk tuples that you're going to use as a way of measuring the quality of um, your uh, pipeline so that you can now run experiments and have a ground truth that tells you is this experiment successful or not successful. I'm going to now show you some code to do exactly that. So I will take over screen sharing. Great. This is all code that we will share a GitHub repository with you. I'll share it in Slack as well as in the course page, and that way you can share this with your team, or you can, I think most people are doing hands-on coding, so you can use some of this code yourself. There are really 3 steps in this code, and I'm going to set aside the first one and focus on the second and third. So broadly speaking, coming back to this workflow that Jason described, you want to get some retrieval metrics. So step 1 is to take your data and put it in a vector database. Just having that data is a step that we do have code for, but since creating the actual data that's in your vector database is you're going to just use your own data rather than synthetically generate it. I'm not going to go through the code for that particular notebook, but then once you've got the data that goes in your vector database, we're going to want to create some questions users might ask so that we can see how good our retrieval pipeline is. So I'm going to go through that. That is in a notebook called Make Synthetic Questions. It's probably a little bit small, so I'll zoom in. So I'll go through that notebook, and then I will show you a notebook where you take those questions and calculate some basic metrics. This week, we're going to use a very simple search mechanism, the most standard sort of nearest neighbors in embedding space. Over time and throughout this course, we will show you many more ways to do retrieval. Those can be re-rankers, those can be extracting data from images as pre-processing. Those can be all sorts of different indices creation. Those can be keyword search. So we're not going to go through all of those today. Instead, we're just going to set up the initial baseline calculation of metrics. When I do this, to make it more concrete, I'm going to do it in the context of a hardware store retailer. So think someone like Home Depot. They are building a feature that lets a user ask a question in plain text and then get that question answered based on reviews for a given product. So in the notebook that I won't focus on during our time here, I'm going to create a bunch of these product reviews. If you actually were a hardware store retailer, you would already have these. But when you create when you're about to spin up your RAG feature, you don't have a large list of the questions that that users will ask. And so you're going to run through a notebook like this, or you can even start with this as a notebook that you modify. The pseudocode is that, and there's some explanation higher above this, but I just explained that in words. So you're going to create some synthetic data. We're going to start with an empty list for that. And we're going to go through all of the chunks in our vector database. For each chunk, we're going to get some questions that are answered by that chunk. And that creates a bunch of these tuples. So I have question, answer, and chunk. And for each of them, I have had a large language model create a question and an answer that is answered by that chunk. And now I have these tuples where I have a ground truth. When a user comes in with this question, here is the chunk that we would like to retrieve. If you were to do this in a very naive way, the simplest way of translating this pseudocode into Python code, there are a few different problems you'll run into. So one is where you want this in JSON format, but to actually make sure that the keys are the same every time so that we can run assertions on it, you need to have really consistent formatting of the LLM's response. There are a lot of ways that you can inch towards that. So those would be providing few shot examples, but using the instructor library is a way to do that much more reliably. The second issue that you'll run into is a lot of times the questions that you get just won't be in the format that you want. We will give some sample questions, and that will improve the quality of questions we get back. Even still, the questions that you get back, they might be something that seems okay to the data scientist, but someone who is more deeply in the business will have preferences that won't be met by the first questions we get back, so that you will have to go through an iterative process with your stakeholders. In the breakout session tomorrow, we'll go into a little bit more depth about that. And then the last is, Jason said, we're not trying to create a dozen of these chunks or pairs of questions, answers, and chunks. We're trying to create hundreds or thousands of them. And so we're going to do this in an asynchronous way so that it executes in minutes rather than hours or days. So I have some code below, which we'll share with you. You can reuse. First thing that we do is we're going to open the database table. Here we use LanceDB, though you can use Chrome or Pinecone or whatever else that has the reviews. I like to work in pandas, so here we're going to see I loaded it into a data frame. Here you can see some example reviews. These, like I said, are all for things you could buy at a hardware store. This hammer has been a game changer for my general carpentry work. That's a little over the top, but that's an example of the beginning of one of these reviews. If we look at the bottom, you can see you've got some for circular saw blades. We're going to iterate through these 384 reviews. For each of them, I'm going to define the data model. I'm going to have an ID. The ID is important because I want to be able to, again, create those tuples and have a way of referencing when I do retrieval, am I generating the right chunk? Here I've got the content of the review. I'm going to have some example questions that we're going to put in the prompt. I specify the, this is setting up async. Here, this is the format of the questions and answers. And then we're going to here show the an example of creating the evals. So here you can see I want to generate questions for a given saw. The answer should be derived from the information in this product review. I give the product review. I give the example questions. I'm just going to have new lines that separate them. And then I say, provide a concise and specific answer for each question. Do not use the exact example questions. Use them only as inspiration. This is an important one. So if you do not include this in your request for synthetic data, if you say do not include answers that are not in the content, they will generate questions for which the answer is not in the content. Then, as LMs do, they'll hallucinate an answer. And now when you do retrieval, you're going to have questions and chunks that aren't aligned with each other. And then This is also an important one. Questions should ask about product characteristics and should not refer to product characteristics rather than referring to the reviewer specifically. If you don't include something like this, then the questions you get back will be things like, what did the reviewer say about durability, as opposed to what was the hammer's durability? And again, we want these questions to be as realistic as possible. I run these with GPT-4o Mini. You can use any reasonably smart model. We generate just the questions and answers. Recall, we are calling this with the chunk as an argument to that function. And as a result, we're going to get back just the questions and answers. And then since we know what chunk they're based on, we're going to create the chunk eval, which is that question, answer, and chunk ID pair. And then we're going to run that for a large number of these chunks. And here we're asking for, you'll see we have number of questions. So for each of these chunks, which is in this case, a review, we're going to generate multiple questions. So I'll show below. Here you can see that for 2 questions on a given chunk. But I'm going to have this process chunk to take a chunk and run this. And then I'm going to process all of the chunks in this function here. Some of you are probably super familiar and experienced with concurrency, but we're using this semaphore as a way of saying we want to be able to run up to 10 requests concurrently. Again, a request to OpenAI takes very little CPU time, but does take, or takes very little of our compute time, but does take a while to wait. So we're going to run this roughly 10 times faster by having up to 10 requests that are happening at once. So we create this semaphore. We're going to pass that to the process chunk, and then it will use those. We're going to wait for all of the results. Then we're just going to concatenate them here. Sometimes when we process a chunk, the LLM will, LLMs can be very unpredictable. So in some cases, we'll get some sort of error, which is typically we couldn't parse the response. We've created this chunk processing error as a way of being specific about that. We'll print those out just as a way of logging them. If you were doing this in a script, you would use Python's logging. I'll save that, and you can see that when we run this, we get 768 chunks that were created. We saved it. We can save it in JSON. We can save it in a database table, but then we're going to use that to calculate metrics. And if you just want to quickly see the result of that data is what you see here. So we have all these pairs of for chunk 0. Here is a question. Here is the answer. And we can now use that to look at, actually, I apologize. I hard coded when testing a product name. They shouldn't all results have Sawzall. I will correct that in the notebook that I share with you, but we can now start calculating some metrics from that. So we've said the metrics that we want to calculate are, there are others, so reciprocal rank and many others, but just precision and recall are good baselines. So now we can load those pairs of chunks, questions and answers. I will, for the reviews, we're going to want to look those up. So here I've calculated embeddings of those. And we're just going to look at those. Here's the products table. Here is the raw data we just looked at. And I'm going to set up evaluation. So that is first loading this data into a structured format so that we can run requests against it. Here is an example of running a simple request with LanceDB. So for each request that comes in, that's a new question, we're going to find the some number of chunks, and the default value is 5, that are most similar to it. We're going to score that for both precision and recall. The way that we do that is we get, when we run the request, we're going to get a list back of which of the retrieved items are exact matches for the correct chunk ID. In this case, that's just going to be a list of Booleans. I have a score function that calculates how many true positives do we have. That is, how many hits did we get? How many total retrievals did we do? And from that, I think most of you are familiar with precision recall. So we can do simple calculations. True positives divided by total retrievals would be precision. True positives divided by the number of requests or the number of items that we retrieve is recall. We return those. And now for, I'll show you just a simple different number of retrievals. I can loop through those and see what the precision on recall is for different numbers that we retrieve. But once we have this, we can keep our score function and just change our retrieval function. And now whatever other changes we want to make in our retrieval, we can extend this table and see if we add keyword search or if we add re-rankers, how does that impact? The thing we care most about is recall, but how does that impact our precision and recall? So that was a bunch of code, but I will share it with you. I'll make that one fix. So I apologize for showing it a version that had that error in the first prompt. But I'll share that with you and you can go through it in your own time. And I've got some explanations here. So it should all make sense and be reusable. Okay. So that covers code. We have, I think the next item up is questions. We should have a lot of questions. Most of them we'll answer in office hours tomorrow, but I think unless there's something else we should cover, Jason, we can take a couple of minutes of clarifying questions now. Let's finish the content and we'll have questions through the Dory at some point. Go ahead. And I think you're muted, Jason.
The general idea is that these questions will be like pretty bad, right? But the idea is really is you want to troubleshoot early and have some kind of data set that allows you to iterate very quickly. And because they're bad, at least there's some thing that you can point to with everyone else on your team to recognize, okay, these are not actually the questions our users are going to ask. Let's go figure out what they really look like, right? I think sometimes, people aren't really thinking about what questions people are asking. They just want to have a question answering system. And this is just a good way of kicking off that conversation. In terms of the homework, I think it looks like about almost 40% of the people here have already done some kind of baseline evaluation. But really, if you use something like LanceDB, it's going to be very easy to test whether or not different implementations of BM25, embeddings, or even the re-rankers can improve your metrics, right? And the goal is that with these baselines, you can choose to do nothing if these experiments don't pan out. And ultimately, when you have questions that have zero recall, you can now go look at them and again, just consistently ask yourself, would it have been possible for me to answer these questions to begin with? For people who have things in production, try to sample a percentage of that traffic and put that in your synthetic data generation. Try to use LLMs as a re-ranker and see how they perform. And ultimately, start setting up this cadence of being able to just review these documents and these questions that have poor recall, right? Because that's going to give you the most intuition on what's going on. And you can try a bunch of different things like embedding models, re-rankers. I'll fix the slide up before I share it. But there's just a bunch of different things that you can try. And once you try all of them, you can start looking at the latency trade-offs against these different retrieval methods, right? In an e-commerce setting, like 100 milliseconds costs you like 1% of revenue. It might not be the case for your situation, but it's sort of it's good to understand like where those trade-offs happen. And yeah, just don't oversimplify these questions. If your recall metrics are too high, blend in more difficult questions. You should make sure that these are not just static one-time creations, but things you improve over time as you collect more data. And this is maybe not needed to be said, but this has happened a couple times before, where just make sure the search implementations that you're using are the ones you're actually testing in production. There's been a lot of times where it might be easier to test something in staging or have something offline, but ultimately you want to make sure that these are the results that your customers are actually getting. And yeah, this week we mostly focused on looking at these questions line by line. and setting up the logging you need to have in place in order to do this kind of synthetic data generation. And then next week, I'm going to focus on this idea of inventory issues and capabilities issues as we learn to segment these things over time. And what you'll find is a lot of these solutions end up not being AI problems, but really around process and metadata filtering. And ultimately, with these benchmarks, really the goal, the thing you want to think about is the ability to start rejecting interventions, right? I think too many companies like try too many things, add more and more things in the prompt, and then you get to a place where you have like tech debt in both the search implementation and in the prompt engineering, and it's pretty gnarly to get started. And that was basically it. I want to be mindful of people's time, so whether or not this is recorded, I'll answer some of the questions on Dory, and then also leave video versions of those answers and post them in the Slack. So let's just jump into that.
And we do have office hours tomorrow to cover a bunch of these.
Yeah, I think the first thing is just calling out the fact that I'll upload all of these slides. My goal isn't just like read off of everything, but I want to make sure that the slides themselves are standalone things that you can reference in the future. In terms of iteratively working on these prompts, so one of the questions was, how do you iteratively create this type of detailed and effective prompts incorporating all the domain and context? The truth is, Sonnet 3.5 is very good at prompt engineering. In fact, it's been trained to write prompts for itself. And so if you go to the Claude workbench, there's actually a prompt generator that you can use. And what you can do is you can just give all this additional context into the model, and it will actually give you a good first version of a draft. Right? After that, a lot of it will be just making sure we have domain experts sort of giving you feedback and saying like, oh, this isn't realistic. Actually, people don't write questions in full sentences. Usually in this format, people have like 3 or 4 word prompts. Those are the kind of things you want to include in your prompts. But ultimately, in my workflow, I use a lot of like 3.5 to generate prompts and then testing and just getting feedback from the users. And what that feedback ends up looking like is just having like an Excel spreadsheet and just forcing people and cornering them and just asking them, please look at this data, tell me if these things are realistic. They're ultimately not going to be realistic, but let's go figure out what that looks like. I think one question.
Let's take this question from Suresh. I had to get on a different call in between. Where do we access the slides and recordings of the session? So everything is on the Maven web page. We'll try and also post things frequently in Slack just as a convenience, but they're going to live on Maven like universally all in one place forever after. So that should be the course page on Maven is where you should, in general, access materials.
Yeah. I'll answer Chris's question as well. So most of the work that I do, I end up saving things in a platform called Braintrust. The CEO of Braintrust is also in the Slack, but I'll share that afterwards. Most of that will be covered in a talk that Zapier will give on how they collect their production data and how they do their data evaluation. I don't know when that session is happening, but I'll share some more notes in the general Slack as well. I think these 2 questions are pretty relevant, which is, do you find there is value in asking LLMs for ratings between 0 and 1? I've heard mixed things on this. Anecdotally, they tend to overestimate their correctness. So to me, this is kind of in the realm of something called like active learning. The idea is that like if I was to make my labelers label this relevancy data by hand, it might take 30 seconds, maybe a minute for them to read everything and make sure things are relevant. The goal with these LLMs isn't necessarily to get the scores, but to change the nature of the labeling task, right? It is much harder to read 2 paragraphs and say whether or not things are relevant, but it's going to be a lot easier to determine whether or not I think something agrees with the label, right? If I have a task that says, here's a question, here's a paragraph, the AI says it's relevant, now I know what to look for. I can start looking for, contradictions. I can look for irrelevant facts and approve that label. And approving that label might take 15 seconds, whereas generating that label myself might take a minute to sort of think about what the context of the question is. And so a lot of this work isn't to just offload the work to the LLM, but to make your job as a labeler easier. And then once you have enough of those labels, ultimately you can try to fine tune a model, try to see if the model you fine tune correlates with labels. But again, that's kind of a cyclical thing, right? All this does is maybe instead of doing a 2-minute human task, it becomes a 1-minute human plus AI task. As the model gets better, maybe you can do even simpler evaluation tasks. But the idea is really to have the LLM accelerate your labeling rather than just sort of like closing your eyes and hoping that the LLM is always going to be correct. Let me see. Yeah, so Willem has a question, which is, in the synthetic data generation process, should we be worried if the answer can be found in multiple documents and chunks? What would impact the calculation of metrics if only one chunk that generated the question was marked as relevant? This is where I think we would use the LLM to do a little bit more augmentation of the data set, right? It's like, at least let's start with a question we know we can answer. And then if we pull relevant other chunks, we can use the LLM to help us figure out whether or not there's something else that's going to be relevant. Because yeah, it is the case that like you're going to have an imperfect measure of precision because we're assuming only one document is relevant. But as we get more questions, we're going to do the opposite. We're going to generate a question, find chunks, and have them review all the chunks, right? If you looked at like Google in like early 2000s, they were just paying thousands of people to just make Google searches and just reorder these things, right? And the idea is that with LLMs, you can do this a little bit simpler and to focus on approval of labels rather than label generation. Let me see what else. Were there any questions, Dan, that you noticed that were good to answer?
We got this last one from Kartik. Comparing product specs, like a 10-pager sort of use case, any way to create this test bench. I think of this as being very similar to so here you've got one document that has many chunks inside it. I think that's not that much different from a bunch of documents that are all one chunk. So break it into chunks and then run it through the question creation process.
Okay, cool. I think one question was, how do you rate LLMs of reliability between 0 and 1? Do you prefer binary labels? I almost always prefer binary labels. Like I really hate like a 5-star rating system for I think a lot of statistical reasons. By having a binary label, again, it just lets you, it forces the language model to commit, and then it forces a human to sort of really figure out whether or not something is relevant or correct. Whereas if you start doing like a 0.5 or a 0.7, it becomes really tricky. So again, like have a label that you agree with. Like ultimately, if you care about ordering your citations or doing some kind of like real ranking system, you might look into other metrics like NDCG, where there's a gradient of scores. But I think for the most part, if we just have like binary labels, relevant or not relevant, those precision recall metrics are going to give you a lot of information on what the issues are, right? And what you're going to find is, like again, in the example of like document ownership, every question that asked for like timelines, or every question that asked for recency, or every question that asked for ownership just got 0 recall. And if you just looked at all the zero recall questions, you can kind of like infer what the issues are in the system that you've built and infer whether or not you're giving enough context to the model. Cool. So I know we're at time. I'm sure people also have other meetings to go to, but I'm happy to stay a little bit longer. If there's any questions people have, we can just answer them in the Zoom chat. Okay, let me see. Cool. If there's no questions, should we just jump over to Slack then and then just answer any questions there?
Yep, let's answer questions there. And if you didn't have questions like immediately, think of anything in the next day, drop them in the dory so that we can talk through them tomorrow.
Great. Take care, everyone. I'll share some more
Thanks.
notes in the general chat. Bye-bye.